All right, 6-3, dividing polynomials is what we're doing today. And so a couple things we'll learn. We're going to divide polynomials two different ways. One, we're going to use long division, and the second way we're going to use synthetic division. So that'll be our first vocabulary phrase, and then the remainder theorem, we'll finish up with that. That'll be the last example. So let's kick things off, though, with some skills check. And 5-1 and 6-1, if you need a refresher, I'll do 1 and 5. You guys do the rest. So number 1, we need to FOIL first. So we're going to get x squared, and then we're going to say plus 3x, and then minus 4x, and then minus 12, and then there's the plus 2 on the end. And we can clean this up as x squared. These two will go together as minus x. These two will go together as minus 10, and that will be our answer. All right, and then 5, let's write everything in standard form. So again, we need to go from biggest exponent to smallest exponent. 4x cubed minus 2x squared plus 5x plus 9. And the coefficients are 4, -2, 5, and 9. Remember, the coefficients are the numbers in front of the x. All right, so let's jump right in. We're going to do long division, and so we've done long division ever since we were in the lower grades, but now we're going to do long division with some variables in there. So I'm going to set this up. X squared plus 3x minus 12. Long division looks like that, and x minus 3 on the outside. All right, so here's what you need to do. We're going to take the leading term, x squared, and divide it by the leading term on the outside in the divisor, the x. So x squared divided by x is just x. Now I'm going to write it right here so that the x's line up. Don't have to do that, but it's helpful just to make sure that you've got every single term. All right, once we've done that, what we're going to do to find the next line down is we're going to take the x, and we're going to multiply by every term in the divisor. So x times x is x squared. X times -3 is -3x. And then if you remember long division, what we do is we subtract straight down. So x squared minus x squared is 0. That goes away. 3x minus -3x is positive 6x. Don't fall into the trap and say 0x. You got 6x there. And then we need to bring down the next term. Hopefully this should be vaguely familiar from algebra or pre-algebra and before that even. So 6x minus 12. What are we going to do? We're going to start over. We're going to say leading term divided by leading term. 6x divided by x, we get positive 6. And you'll notice once again that the constant is above the constant. So now let's distribute back in. What's 6 times x? 6x. If you did it right, those two numbers should match up exactly. What's 6 times -3? -18. And we're going to subtract straight down. Okay, and so now we've got 6x's cancel, minus 12, and then minus the -18 turns into plus that, so we're going to have positive 6 down here. Okay, and the way we write the remainder is plus 6 is our remainder. We're not going to write R6. With the remainder, we're going to say 6 over whatever the divider was, x minus 3. So I know this has gotten a little messy. Let me rewrite the final answer. X plus 6 plus 6 over x minus 3. Okay? All right, so those are all the steps. Go ahead and see if you can do the exact same things on number 1. Okay, so now let's determine whether x plus 4 is a factor of each polynomial. They'll be a factor if we don't have a remainder at all. So we're going to have to do some long division for both of these. If there's a remainder, not a factor. If the remainder is 0, then it's a factor. It goes in clean. So we're going to do x squared plus 6x plus 8 divided by x plus 4. All right, x squared divided by x is x. Distribute back out, we get x squared plus 4x subtract straight down, we end up with 2x. And we bring down the 8 for plus 8. And let's start all over. 2x divided by, remember, leading term out here is 2. Distribute back in. 2x, and 2 times 4 is plus 8. And look at this. We're going to get 0 down here. No remainder at all. X plus 2 is a factor. It is a factor. That's a check mark. All right, what about this other one here? Let's check this. X plus 4, is that going to go into x cubed plus 3x squared minus 6x minus 7? Let's find out. X cubed divided by x is x squared. Bring it down. X cubed plus 4x squared. Subtract straight down. And we've got negative x squared. Bring down the 6x. And so negative x squared divided by x is minus x. We'll get negative x squared minus 4x. Subtract straight down. We get negative 2x, not negative 10x. Careful with your negatives. Minus 7. Negative 2x divided by x is negative 2. We get negative 2x minus 8. And when you minus your negative, you end up with 1 down here, so plus 1 over x. That's the long one here, x cubed. I'm sorry, x plus 4. Okay? And so that is not a factor. All right, so your turn. Go ahead and see whether these are factors of each other. Okay, so now we're going to introduce a kind of shortcut method here called synthetic division. And the shortcut only works with linear factors, so only if it's a binomial. 2 terms here, x to the first plus a constant plus or minus a constant. All right? In synthetic division, we're going to omit all variables and exponents. I'll show you that in a second. So we really are only caring about the coefficients. 3, negative 4, 2, negative 1. And then instead of using positive 1 here, we're going to use negative 1. Right? Remember, negative 1 is the 0 here. That's what would make x 0. So we're going to use negative 1, and we're going to add straight down. So a couple steps here. I'm going to take all my coefficients and write them out. 3, negative 4, 2, negative 1. I'm going to draw a bar like this underneath, kind of a long L. On the outside, I'm going to put the 0, negative 1. Right? That's coming from this. Negative 1 plus 1 makes that 0. All right, here's how it works. I'm going to take the 3 and make it go straight down. I'm going to times negative 1 times 3 and put it right here. That's negative 3. I'm going to add straight down and get negative 7. Then I'm going to multiply again. Negative 1 times negative 7 is 7. Add straight down is 9. Negative 1 times 9 is negative 9. Add straight down, we get negative 10. And to finish this up, we put the exponents back on. This is 3x, not cubed anymore, but squared, because we divided by x. So it's always going to be 1 less. Minus 7x plus 9 minus 10 over x plus 1. Because we're dividing by the x plus 1. All right, so see if you can follow those steps and work out the answer here using synthetic division. All right, real world word problem here. The volume in cubic feet of a sarcophagus, wow, excluding the cover, can be expressed as the product of its 3 dimensions. The 3 dimensions end up with this as your volume. X cubed minus 13x plus 12. The length is x plus 4. Let's find the linear expressions with integer coefficients of the other dimensions. Assume that the width is greater than the height. Okay, so let's divide this by this, and we'll end up with the area, right? Getting the width and the height, and then we can factor that again. So let's start by doing some division. And I'm going to do this using synthetic division because this is a binomial. So 1 for x cubed, 0 for x squared. You got to have a placeholder here because this is x cubed plus 0x squared minus 13x, so minus 13, and then plus 12. Don't have to put the plus there. All right, out here we're going to have a negative 4. Bring down the 1. We've got 1, negative 4. Add those together, it's still negative 4. Multiply those together, and you get 16. Add straight down, you get 3. And 3 times negative 4 is negative 12. Hey, look at that. There's no remainder. That's nice. So we've got x squared minus 4x plus 3. That's the width times the height, but can we factor that? I think so. X minus 3, x minus 4. And then it says the width is greater than the height. So which one of these is greater? That would be the width. That would be the height. Because minusing 3 is better than minusing 4. So that's the width, that's the height. Let me write down the length again. X plus 4. That's the length. And we can do part B. If the length of the sarcophagus is 10 feet, what are the other two dimensions? So x plus 4, the length, is 10, which means x must be 6. So let's find out the width. For the width, x minus 3. So 6 minus 3, so the width is 3. And the height is x minus 4, so 6 minus 4. And the height is 2. All right, so that would be a 10 by 3 by 2 sarcophagus. All right. See if you can use some synthetic division here for our skills check, and then factor it once you get your answer. And here we go. Last stretch here, we're going to introduce the remainder theorem. So, remove this. In example 1, you saw that x minus 3 is not a factor because it had a remainder, right? And then if x minus 3 were a factor, then 3 would be a 0, okay? So, right, if you had 0 as a remainder, if it came out clean, then you would say that this would be a factor, okay? All right. You know that plugging in 3 doesn't get you to 0, but what does it equal? Okay, if you plug it in, it turns out you get 6, the remainder, okay? So that's actually what we're going to say here. If a polynomial of degree bigger than or equal to 1, okay, so you have to have at least an x, is divided by x minus some number, where a is a constant, then the remainder is what you get if you plug that number in. Let me see if we can make that a little more clear here. We want to use synthetic division to find p of negative 4 for this. What this is saying is, if I plug negative 4 in for x, what am I going to get? Well, that can take a little bit of time because you've got to plug it in and then raise it to the 4th and then square it and then add 4x, right? Let's just use synthetic division and the remainder theorem to tell us. So, we're just going to do our synthetic division. 1, placeholder 0, negative 5, 4, and 12. We're going to plug in negative 4. Okay, plug it straight in. And use your synthetic division to figure out what you're going to get. 1, negative 4, add straight down, add straight down, negative 44, add straight down, you get negative 40. That's going to be 160. Add straight down, you get 172. So the remainder is 172. And what the remainder theorem tells us that is if you plug negative 4 into x, the answer is going to be 172. All right? A lot faster than plugging it in for x, and plugging it in for x, and plugging it in for x. So, your turn. Wrap this up. Last one to try. Uh-oh, where'd it go? Pause for a second. Let me get it for you. It's not in there. 1 second. All right, there we go. There's your last one. Plug in negative 1 using synthetic division and see what you get. All right, any questions? We'll go over this in class. Good luck.